Something that frustrates a lot of students is as they're working through equations and they come up with solutions, then they have to go back in and plug in those solutions to see if some of them work and some of them don't. And that doesn't make sense to them because they've just solved it algebraically, and it just seems that if one of them's going to work, then obviously you've solved it correctly. So why doesn't all of them work? And the answer is a little bit complicated, but a simple way to look at it is using an example like this, where we start off with something that, like square root of 15 minus 2x is equal to x. Now, in this case, we're already concerned with this expression here. If we plug in our solutions and this expression becomes negative, obviously that's going to be a problem. And really the way this is written, x can't be negative because we're looking in this case for the principal square root. The principal square root's always positive. So we're already looking right now at a very limited number of solutions, or at least we can see where there's going to be problems. But to solve this, the first thing that we're going to do is we're going to square both sides, which gives us 15 minus 2x is equal to x squared. And all of a sudden, all those things that we were concerned about before are no longer a part of this problem because we've squared both sides. And so now those negative numbers aren't a concern anymore because we've manipulated the equation. We've now made it a second degree equation, which means we're expecting at least two answers, which isn't necessarily the case up here. So if we were to go ahead and solve this, we're going to move everything onto the other side. So we're going to rewrite this as x squared plus 2x minus 15 equal to 0. We're going to go ahead and factor that. Now, because this is negative, we know that we're going to have a negative and a positive here. We've got an x as our first term. Now we need factors of 15 with the difference. Since this is negative, they need to have a difference of 2. And in this case, it's going to be 3 times 5. And because we're going to have a positive 2, a positive 5 minus 3 gives us a positive 2. So that's how we would factor our equation. Now, in order for this to be equal to 0, either this has to be 0 or this has to be 0. The only way this is going to be 0 is if x is equal to negative 5. The only way this is going to be equal to 0 is if x is 2. Let me rewrite that. I said 3 and then I wrote 2. So this, in order for this to be equal to 0, x would have to be equal to 3. Now you can see really quickly just from that example why you can make mistakes, because sometimes your brain is thinking something, you write it differently, and if we would have continued on here, we would have run into all sorts of problems. But our only possible solutions now are x equal negative 5 and x equals 3. We've already established that this can't be negative because of the way our original equation was written. So let's try this x equals 3. So let's rewrite this equation up here. Negative 15 minus 2x is equal to x. Let's plug in our 3. So we get the square root of 15 minus 2 times 3 is 6 is equal to 3. Well, 15 minus 6 is equal to 9, so we get the square root of 9 is equal to 3, or 3 is equal to 3. So 3 is our solution that works. Negative 5 is an extraneous solution, doesn't work because of the way our original equation was written. So whenever you start squaring and taking roots of or anything like that with an equation to help you solve it, you're adding in the possibility of additional extraneous solutions. You just have to plug everything back into your original equation to make sure that all the changes that you made didn't introduce some of these false solutions into the problem. So I hope that helps. As always, please like and subscribe. Pass this information on to those who it might be useful for, and thanks for watching.